Ever since man started to look up to the sky, he always dreamt about going far into space, searching for new planets, especially ones that could support life. Well, now we have crossed a tremendous cosmic milestone. Yes, NASA now confirms the presence of 5,000 exoplanets. Exciting, right? Just think about it. How would they look like? Would they support life? Yeah, in today's episode, we will be answering these questions. Let's jump straight into it. Hey folks, hope you guys are doing good. Welcome back once again to Skies TL. What are you guys waiting for? Like, share and subscribe. What did you expect these planets would look like when we first asked? What was the first thing that sprang to your mind? Is there a planet that rains glass or pours fire? Let's see what happens. Verified exoplanets have now surpassed 5,000, marking a 30-year odyssey of discovery headed by NASA space telescopes. Not long ago, we lived in a cosmos with only a few known planets, all of which orbited our Sun. However, a recent slew of discoveries marks a watershed moment in science. More than 5,000 planets are now verified to exist beyond our solar system. On March 21st, the planetary odometer was reset when the current batch of 65 exoplanets or planets outside our solar system were uploaded to the NASA Exoplanet Archive. This repository contains exoplanet discoveries that have been verified using various detection methods or analytical techniques and have appeared in peer-reviewed scientific journals. The 500-plus planets we are discussing include tiny, rocky worlds like Earth, gas giants, which are many times the size of Jupiter, and there are these hot Jupiters in dangerously tight orbits around their stars. Apart from these gas giants, there are super-Earths, which are potentially more significant rocky worlds than our own, as well as mini-Neptunes, which are smaller copies of our system's Neptune. Add to the mix planets orbiting two stars at the same time, as well as planets orbiting the collapsed remnants of dead stars. That's another story to speak about. This 5,000 is more than simply a figure. It's more than a number. Each represents a new world, a brand new planet, and we become thrilled about each one as more information about them is disclosed since we don't know anything about them. There are probably hundreds of billions of such planets in our galaxy, and we are just at its tip. The constant drumbeat of discovery began in 1992 with the finding of bizarre new planets around a star. Not just some star, a strange one. It was a pulsar, which is a fast-spinning stellar corpse that pulses with millisecond bursts of scorching radiation. Scientists discovered planets in orbit around the pulsar by measuring minor variations in the timing of the pulses. The discovery of merely 3 planets around the spinning star basically opened the floodgates to the discovery of many more. Did you know that neutron stars are fascinating ones? Yes, if you can locate planets near a neutron star, you can find them pretty much anywhere. Around these stars, the planet creation process must be pretty vigorous. The first planet discovered was a hot Jupiter, a gas giant roughly half the size of our own Jupiter in a 4-day orbit around its star. In other words, a year on this planet lasts only 4 days. Once astronomers learned to recognize them, dozens then hundreds of such planets appeared in data from ground-based telescopes. They were discovered using the wobble approach, which involves measuring a star's small back-and-forth motions induced by gravitational tugging from orbital planets. However, nothing appeared to be having livable conditions. Finding tiny rocky worlds similar to our own needed the next significant advance in exoplanet hunting technology, the transit approach. The concept is to connect incredibly sensitive light detectors to a telescope and then launch it into orbit. For years, the telescope would scan a field of more than 170,000 stars looking for small dips in illumination as a planet crossed a star's face. The Kepler Space Telescope achieved this concept, which gave us a lot of planets. Okay, let's keep that all aside for a moment. Let's sum up everything. In short, we are entering into a new age of discovery that goes beyond merely adding new planets to the list. TESS, or Transiting Exoplanet Survey Satellite, was launched in 2018 and is still discovering new exoplanets. But starting with the new launched James Webb Space Telescope, which is a powerful next-generation telescope, and its incredibly sensitive equipment could soon collect light from the atmospheres of exoplanets, detecting which gases are there to potentially find telltale signals of livable settings. And if we find one, that could be a whole new chapter for us. It is certain that we will come across some form of life, most likely a primitive form of life. The strong relationship between the chemistry of life on Earth and the chemistry found throughout the cosmos and the finding of common organic compounds implies that the detection of life itself is simply a matter of time. The Nancy Grace Roman Space Telescope, which is scheduled to launch in 2027, will use several approaches to discover new exoplanets. The European Space Agency's Ariel mission, which will launch in 2029, will examine exoplanet atmospheres. A piece of NASA equipment aboard, named CASE, will assist in identifying planetary clouds and hazes. That's a new door or window for us to peep in. Why don't we take a look at all planets we could find in these 5,000? What kind of planets could be there? This is where things start to get serious. We used to believe that our solar system was typical, with planets falling into one of 2 or 3 groups. We knew there would be solid, terrestrial planets akin to our solar system's 4 inner planets. We also believed that there would be gas giant planets such as the 4 outer planets, with some splitting them into the subcategories of real giants such as Jupiter and ice giants such as Uranus, Neptune, and according to certain classifications, even Saturn. We can classify these planets and discover what's out there. We have discovered that the majority of discovered planets, while still biased towards higher masses, shorter orbital periods, and serendipitous orientations relative to our line of sight, fall into an in-between state, more massive than Earth but less massive than Neptune or Uranus, with Radii in the middle. The majority of these worlds are most likely mini-Neptunes rather than super-Earth, but more research is needed before we can be certain. Okay, that's all about exoplanets. What about our solar system? Is it typical in some way? Both yes and no. We know it's a lame response. Our solar system is most likely normal in terms of the number of planets. However, the low mass end of the exoplanetary spectrum and the population statistics of the outer planets in most planetary systems have received little attention. However, we are likely atypical of the ordinary in that we have a succession of rocky, terrestrial planets in the inner solar system, followed by more massive, gas-rich planets in the outer solar system. Other systems we've studied have revealed that big planets in the inner reaches of planetary systems aren't uncommon but rather abundant. We've also observed that these mini-Neptune planets make up the vast bulk of the exoplanets we've mistakenly dubbed super-Earths, are quite frequent yet not represented in our solar system all. Finally, there are 2 truly astonishing ways in which we differ from the norm. Our Sun is brighter and more massive than 95% of the stars in the galaxy, and about half of all stars are members of multi-star systems. But if you guys want to know how typical we really are, we must first understand what is going on around the more frequent sorts of stars. But that's a whole different story for another day. For generations, our predecessors and we gazed up at the sky, awestruck by the seemingly infinite specks of light shimmering in the skies. While many speculated that they may be identical to our Sun but positioned a great distance away, no one knew if our solar system was unique. If you ask us, we could say that there might be more systems like ours out there, containing either primitive civilizations or even a highly advanced civilization, maybe a level 1 or 2. Who knows? They might even be among us, may have been already acknowledged our presence in the universe. Well, from what we have right now, we know that these are just a fraction of the likely hundreds of billions in our galaxy. The cones of exoplanet discovery radiate out from planet Earth like spokes on a wheel. Many more discoveries await, and we here at Skies TL will be bringing more data to you. So coming to the end of the video, what do you think of this achievement? Moreover, what do you think of today's episode? Anyways, drop in your views about today's video in the comment section below. That's about it for today. Make sure to subscribe to our channel for more content just like this one. And while you are at it, turn on post notifications so that you never miss out on any of our future uploads. Drop a like for the video if you've loved today's video. Hope you enjoyed the video. We will meet again in the next one.